mathematics. We are exploring about simultaneous equations. And then in today's lesson, I want us to look at the simultaneous equations that involve fractions and how we can best work with them. Alright, so looking at simultaneous equations that involve fractions, we want to take two or more equations at the same time, whereby we are going to get one of the equations having a fraction, or both equations, or maybe the three equations having fractions, and then we have to simplify them. Now, when you happen to have a fractional part in any simultaneous equation, make sure that if the fraction is just 1, then you have to you use the denominator of that fraction to multiply all the terms in that particular equation. If the fractions are more than 1, then look out for the denominators and then pick the denominators. Use the denominators to get your lowest common multiple, that is the LCM. After getting the LCM, use the LCM to multiply through you are going to multiply all the terms by the LCM that you have gotten from your denominators. And by doing so, your denominators are going to cancel out. And then you get your linear equations and you can be able to simplify them easily. So we explore one or two questions and then I give you something to try at your own free time. Okay. So from the question on the board, you can see that equation 1 contains fractional units or fractional parts. And the question reads 1 over 2x plus 3 over 4y is equal to 2. That is equation 1. And then equation 2 is x plus 3y is equal to 7. And then in equation 2, you can see clearly that there is no fraction. So what do we do now? Now we work with the equation 1 first. We want to make sure that the equation 1 is also in a linear form. Then we can be able to work with equation 2 and then equation we are going to get. Now when we take equation 1, now I'm to multiply through by 4, which happens to be the LCM of 2 and then 4. So the two denominators, their LCM is 4. After getting the 4, I'm going to multiply all the terms by the LCM, which is the 4. Okay. Now this 2 cancels this 4 2 times. And then this 4 also cancels itself 1 and cancels your 1. I have 2 times x, which is 2x, plus 3 times y, which is 3y, is equal to 2, 4, 8. So I have 8 over here. Okay. Now I can name this as equation 3. Now I'm going to work with equation 3 and then equation 2. Since they are all in a linear form, I can work with these two equations now. Now over here, I can use the elimination method, I can use the substitution method. But when I consider the equation 2, the coefficient of x over here is 1. And so if I want to make x the subject in this case, it's going to be very easy for me. And if I'm to make x the subject, that becomes the substitution we discussed the last time. So I'm using the substitution method to work this one. Now I've gotten equation 4, and then equation 3, equation 2. And then from here, I'm going to put equation 4 into equation 3. So this is equation 3, equation 4. I'm going to put it into equation 3. I cannot put it into equation 2 because I made x a subject from equation 2. And so if I put x equation 4 into equation 2, I'll get 7 is equal to 7, which is not what we are interested in. So I have to put equation 4 rather into equation 3. And by doing so, I get 2 times 7 minus 3y all plus 3y is equal to 8. 2, 7, 14, 2, 3, 6 plus 3y is equal to 8. Minus 6 plus 3, that should give us minus 3. So minus 3y is equal to 8, 8 minus 14 minus 3y. This is going to give us minus 6 divided by 3, negative 3, y becomes 2. Now I put y back into either equation 4, equation 1, equation whatever. Then I get a corresponding value for x. It will be simpler if you put it in 8 into equation 4. That becomes x is equal to 7 minus 3 into bracket 2. X is equal to 7 minus 6. X is equal to 1. Therefore, x is equal to 1. And then y is also equal to 2. Right? So this is how you go about it if you have it in this form. Now let's look at another situation where you are going to have equation 1 and equation 2 all having fractional parts. How do you go about that one too? So let's take that question. Then we see how far we can go with that one too. Alright. Alright, so I have equation 1 as 6 over 5a plus 3 over 2b is equal to negative 4. And then equation 2 also as 1 over 3a minus 5 over 4b is equal to 1. So you see in this case, the equation 1 and equation 2, they are all having fractional parts. And so I have to find the LCM of each of the equations. And then I simplify the equations to get a linear equation. Then from there, I can be able to work with the linear equations. Alright, so let's do that quickly. Now, first of all, we take 5 and then 2. What's the LCM of 5 and 2? That should be 10. So I have 10 times 6 over 5a plus 3 over 2b times 10 is equal to minus 4 times 10. This gives us 5 here 1, 5 here 2, 2, 6, 12, 2 here 1, 2 here 5, 3, 5, 15, minus 4 times 10, minus 40. We can name this as equation 3. And then now we take this one too. We have, what is the LCM? 12. 12 times 1 over 3a minus 5 over 4 times 12. 1 times 12. 3 here, 1, 3 here, 4, 4 here, 1, 4 here, 3, 4, 1, 4, 4, 8, 3, 5, 15, b is equal to 12, equation 4. Now I have equation 4, equation 5, and then they are all in a linear form. So since they are all in a linear form now, it is very easy to work with this. Now when we observe this carefully, we can see some sort of elimination over here. When we take the equation 3, we have 12a plus 15b. Equation 4, we have 4a minus 15b. The coefficients of b in both equations are the same. So we have to eliminate them either by addition or subtraction. And then over here, because the coefficient here is carrying a negative operation, and the one over here is carrying a positive operation, we have to add the two so that we can eliminate the b over here. This is 16, then this sign goes out, leaving this plus this minus 52. Sorry, that will give us okay. So this is going to give us 40 minus 12, 8, so 28. Okay, so divide by 16, divide by 16 is equal to 28 over 16. 2 here, 14. Okay, 4 here, 7. 4 here, 4. So a is equal to 7 over 4. We find the value of b. B is equal to, which equation should we put it in? Equation 1, 2, 3, or 4, or 5? Okay, so we can put this into equation 4. So we have 4, 12 times 7 over 4, like this. Minus 15b should be equal to 12. 4 here, 1, 4 here, 3, 3, 7, 21. Minus 15b should be equal to 12. 21 minus 12 should be equal to 15b. This is going to give us 9. 15b. Divide by 15, divide by 15. b is equal to 9 over 15, which is the same as 3 over 5. Okay, so we have the value for a as 7 over 4, and that of b as 3 over 5. Okay, so as usual, I solve one or two examples, then I give something to try for yourself as well. So this is your assignment for the day. Alright, so I'm giving you a clue. I'm giving you answers so that you work towards these answers. Okay. So at the end of the day, you are going to get x to be equal to 10 and then y to be equal to negative 3. So this is what you should be expecting. Work towards this answer and then enjoy the rest of your day. Thank you. Please subscribe to the channel. Bye bye.